So one of the first hurdles in my class that I've seen is students struggling to get over generics and how to properly use generics and what even is a generic. So this is going to cover that. But first, before we can cover that, we've got to make sure that you understand what an array list is. So let's go ahead and start with that. So in your first Java class, you should have learned about arrays. So here I'm going to create a very basic array of integers. So int array is equal to new integer of size 10, and so that creates a integer of array with 10 items in it, and it will look something like this with 0, 0, 0, 0, 10 of those. Right? Okay. So let's go ahead and maybe go ahead and put something into it. Right? So actually, let's put something in all of them. So for int I is equal to 0, so from index 0 all the way through the last index, I is less than array dot length. I plus plus. And we go up to, but don't include the array length, because the array length is always, which in this case is 10, is always one bigger than the very last index, which is 9, right? So this is indices 0 through 9 in this example. Okay? So the idea here is maybe we want the array to hold each of the a value equal to the index squared. So, for example, what we want maybe is for the first index to hold 0, because 0 squared is 0. Second index, so index 1 will hold 1. Index 2 will hold 4. Index 3 will hold 9, and so on and so forth. All right? So what we're going to, so in order to do that, we say array at index I. What we're going to do is we're going to store at index I the value I times I. Okay, fairly straightforward, and we'll go ahead and print it out to make sure that it works. So arrays dot toString, right? We'll convert. That is not what I want at all. Arrays dot toString array, so turn that array into a string, and we need to import the write package for that. Okay, and of course we actually need to print that value out, so system.out.println. Right, convert the array into a string, then print out that string, and there's all our values. Okay, so let's go ahead and just, hold on. Paranoia, I was just checking to make sure the camera was working. Alright, so, and that's great. And if I wanted to change the length of the array, I have to change it over here, right? Can't change it in the middle of the program, right? Once I create an array, its value is set in stone. I can't change it anymore. So I can't change it, period. So here, right, I can't just add one to the end of this array, add one more element to the end of this array. So int array, right, so if I can't, so here I have, let's go ahead and switch this over to back to 100. So we have indices 0 through 99. So if I wanted to do this, right, set the index 100 equal to 1, I'm going to get an error saying that my array has gone out of bounds. It is just slightly too big, maybe. So edit to 14. Apply. Yeah, it's better. All right. So, now you can imagine though that this is a bit frustrating. that there would be a lot of instances where you would very much please like to increase the length of your array. You know, and be able to do it multiple times. You'd not like to have to try to figure out how many items you will need at before you run your program, right? So that's where an array list comes into play. Now, an array list is a type of list, which we will go into way more detail, as you'll see in the lectures that are during the actual lectures themselves. This is just here for the purposes of making sure you understand generics. But again, in order to know that, you got to be able to use an array list. Okay? So, what an array list works like at the very, very basic level is that it's a really smart array. It's an array that resizes itself. So ArrayList, and I'll just leave it without the generics first. ArrayList list is equal to a new array list. So it's an object. And what it does is essentially, underneath the hood, as you'll see in class, it's just an array. It's an array completely underneath the hood. And what it does is that it resizes at will as you need it. Okay? So, alright, so initially, let's see, so first off, when we create new things like this, I like to see what happens when I print them out. So, created a new list, and let's go ahead and print out that list. And it says, hey, it looks like an empty array for the output. Okay? So, list.put, list.add 1. So we're going to add 1 to this array list. Add 2. So we can use the add method to start adding things to our array. So let's go ahead and rewrite that loop. For int I is equal to 0, I is less than, and rather than setting up a length of the list, what we're going to do is that we are going to go ahead and just add however many items we want there. Bad programming practices. Okay, list.add I times I. And so now let's run it. And this just magically grew to however big we needed it to. Okay, that's pretty cool. Let's get it down to a much more manageable size. Okay, cool. Now, okay, the next question is if it dynamically resizes when you add it, what about when you add to it? What about when you remove from it? Excellent question. From the view of the user, you can just simply remove something from the middle. So remove index 2 from our view using this data structure. If we remove this, system.out.println, run this, 0, 1, so we removed index 2, which was the value 4, and 9 and 16 are still there. We just simply removed the first one, and if I were to print out the length of this list, it's a list, so we use the term size, as you'll see. It's going to come out as 4. Now, there's actually quite a bit that, again, goes on underneath the hood that we'll get to, but for now, that's really all you need to know about them. So for an array, we'd say array.length. Here we're going list.size. To add something, we just say add it. We can remove something, which that's pretty cool and new. And what if I just want a specific value from it? If I want to get a value at a specific index, then I use the get command, the get function. So get 2. And we can also do that in a loop for int I is equal to 0, I is less than list.size I plus plus list.add. So I'm going to add list.get. So since I is equal to list.get, well, we already have I, so of course the int val is equal to list.get index of I. Sorry, this is just thinking ahead. All right, so well, that's interesting. Well, what's going on over here? Well, the way this works is that that underneath this is an array of objects. So there's underneath this array, it doesn't create an array of integers. It doesn't know that you need integers. We haven't told it that we need integers. So it doesn't know what we're going to be stuffing into this. So it says, okay, I need something that can hold anything, and the type of object that can hold any object is an object. Ignore the fact that an integer is not an object right now. We'll cross that bridge when we get to it. Okay, so we just go ahead and add an integer in there, and when we get something out of it, it's going to return an object, and it's warning us, hey, we can't convert a random object into an integer. So we're just going to have to tell it, it's okay. You can trust me. So, however, that seems a bit, if you think about that for a minute, this is an array of objects underneath here. That seems a bit dangerous, right? Because right over here, I have to do this, hey, Java, trust me, it's not an object. I've actually got an integer stored in there, and I don't know about you, but I am not exactly the most organized person in the world. I'm also, easily distractible, and I have terrible memory. If this sounds anything like you, raise your hand. So I can easily forget, hey, what was I actually putting in here, right? Was it integers? Was it doubles? Was it strings? Was it some other custom type? Now, of course, one way to get around this is, is by giving it a better name like iList for integer list, but you're lazy. You're not going to do that. You should, but you're not gonna. So this seems, so the danger here is, of course, we can forget what we put in here. And if we forget, then it becomes very easy for me to do something like this. Just somewhere, imagine there's a whole lot more code in this giant program that I'm writing, which, of course, I shouldn't write giant programs, but, there's a lot of things you do as when you're beginning to develop that you do. So, list.add hello. Now, of course, if we were just outputting the value directly like this, if I were just doing this, this would be fine. Where I just simply get the value and print each one of them out. 0, 1, 9, 16, hello. That's perfectly fine, right? It's an array of objects. That's why hello could get stuffed in there with the ints. Okay. So, but when we get over here, when we go back to the way we were doing it, where we convert, run it, we're going to get an exception, right? Class cast exception. String cannot be cast into a integer. You can't turn a string into an integer, right? Makes sense, right? Because we were saying, hey, Java, trust me, it's a integer coming out. So no need to, throw that error. And then we run it, and Java tells us, hey, you totally dropped the ball. You said it would be an integer, and it's not. So that's a bit of an issue. So it becomes very dangerous to add stuff when you do this. It becomes easy to add things. So one solution about that, so a solution for this is generics. So the idea here is that we can mark this list so that it only has, that it takes in only one specific type. Okay, so it's going to look a little weird, but we can tell the array list that we want an array list of integers. We want an array list of strings. We want an array list of booleans. So I'm going to go ahead and try this again. Okay. Array list of strings. So this is how it looks like. I'm just going to back up for a second because we did have these warnings that were warning us. All right, we have ArrayList is a raw type, references to generic ArrayList E, and that should look like, and that looks like, you know, something super scary, but it's not. Should be parameterized. It's a bunch of gibberish from your perspective if you don't know what a generic is. And we got a warning here when we tried to add something. It says, hey, you should infer the type arguments or the generic arguments. The warning is that it belongs to the raw type. What does that mean? It's just a warning saying that we're not using generics. And what we can do when we use generics is that we can say this is an array list of something. So say I want my array list, this list object, to only have strings. I can type in string. And what all it is that the way you read this is that it is an array list of string. Array list of strings. This means that inside the array list, we are just storing strings and nothing else. And we've still got a warning over here because we need that to match, right? Okay, it's got to match. Obviously, this, you know, you can't say that you have a new array list of integers and that's a new list of strings, right? They've got to match. Okay, so now something interesting happens as a result. List.add. If we look at the autocomplete over here, it says that the add method is a string. What was it before? Right? It was just flying up there, and we didn't really get the chance to look at it earlier. List.add was object earlier. By adding in these generic arguments, these generic parameters, rather, it changed to string. Okay? What if I change it to, let's see, for some reason, array list of scanners? I'm trying to choose stuff that you would have easily been exposed to in the CS1 class. Import. Add scanner. Right? Changes it to scanner. So now we have the ability to, so now if I were to try to add an integer to this array list of strings, it's going to tell me I can't, in fact. It's going to tell me, hey, you can't add, we're expecting a string, right? And you gave me an int. That doesn't work. So that's pretty cool. It prevents that entire thing that we were going on about. Now, so we can use this for any type of object we want. We can create an array list of any type of object. We could even create an array list of array lists. But importantly, it has to be an array list of objects. I can't do this. An array list of ints, right? Ints are primitives, right? So instead, what I need to do is, right over here, it's expecting me to give it an int array, which is why it's asking for dimensions, I bet. So here, we want an array list of, instead of ints, we're going to use integer, obviously. Integer. Well, what is integer? Well, to review, Java has a cool feature called Autoboxing and Auto-unboxing. So integer I is equal to a new integer. 5. Int x is equal to 5. Ooh, that's interesting. It says the constructor is deprecated. It says don't use it. All right, fine. So what happened over here? So what's going on over here? So an integer is what we call a wrapper class. And the wrapper class means that we can take this integer x and automatically convert it into an object that holds integer values when we need it. So integer can just stand in place for an int anytime where we need an integer. And here I can prove it. All right, so let's write a very basic function, public static int add int x int y, oops, return, let's actually be obtuse about this for a second, x plus y. Return the sum. All right. So, obviously, if I do this, system.out.println, okay, and 1 and 2. This will return 3, unless the universe has gone terribly wrong. Hasn't, so it returned 3. Okay. What I need to do now, what else can I do? Well, I can do integer I is equal to 5. So let's go ahead and stick I there. So it took it, and it was asking for an int. I provided an integer. Java doesn't really care. You can interchange ints and integers pretty much at will. This is useful when you need an object instead of a primitive. 7, right? And it works the other way too. Right? We're returning an int, and the value we're actually returning is an integer. Converts them. It's fine. So you can use those interchangeably. You've got them for doubles as well. Surprisingly, assuming I can spell double. Double. Character. For characters. For chars. It's annoying that that's so long, but whatever. And you'll never guess what Boolean is. I mean, okay, maybe you probably did. Okay, so that's how generics work. So now where it gets a bit complicated for some students is writing a function that uses an array list, right? So public stat. So say you want to write a method that finds the largest value in an array list. Okay, public static. Let's see, int. Let's see, int. I'm just thinking about the largest value. So let's say the largest integer in an array list. So public static int biggest int in list, because why not create obtuse names? We're not mathematicians who say let's use a letter variables from dead alphabets everywhere. So let's see, if we did that, that'd make our keyboards really big. So ArrayList so I mean, and you can see where generics kind of come in handy here. The idea here, and the reason being, is that if we were writing this like finding the biggest value in an array, right, the first thing we'd want to do is say, hey, so our biggest value is equal to int max is equal to the first item in the list, so list.get, and get index 0, the very first item in the list. And the first thing we have to do is convert, right? We have to do conversion there. And then anywhere else we'll pretty much have to, anywhere else where we do a get operation, we'll have to do a conversion, right? If we just take an array list, because this is an array list of who knows what, probably just, and could just be objects. And of course, if I pass an array list of strings to here, it will crash. So this method we can adjust to say it takes in an array list of integers. And now we don't need to cast anymore, because we can, and this method will only work with array lists that have integers in them. So that's pretty cool. So now we can just complete the program. For int I is equal to f. We can actually also use, I'm going to instead use the for each loop instead. So for int val in list if val, and I can use this, of course, only because I don't care what the indices are. If the val is greater than our max val, max is equal to that val. Okay. Array list of integer int list. Okay, new array list, and let's go ahead and set it up. Random r is equal to a new random. Let's give it a seed, so if we run this a bunch of times, it will run exactly the same time. Import it. Okay. Give it a better name. And now for int I is equal to 0, I is less than 10, I plus plus, rando.get next int. Let's go ahead and say to 100. Let's add to 100. Oh yeah, I should probably remember what my variables are called. I mean, this is what happens when you do these things spontaneously. Okay. And of course, maybe print that out. So system.out.println the int list that we just created. Right? So we've got a bunch of random integers, and because I gave it a seed over here, this means that it's going to produce the same random numbers each time. If I change the seed or don't give it one, it's going to come up with something different, but I like to be able to repeat what I'm doing in these. So the biggest one in these is 89. So now system.out.println, we call, and of course, biggest int in list. And this should output 89. Awesome. So it works. I mean, the professional tester should probably tell me I have to do a lot more tests than that, but you know, brevity. And what's fantastic about this is that we can now, is that only the array list of integers will be taken into that function. So C gives me an error if I try to give it an array list of strings. So I think that's enough for right now. So see you in the next one.